Okay, so we are moving into the final lesson of chapter 4. Go grab Mason for me, please, and tell him to come on back in since we're ready to start our usual lesson. Okay, so the final lesson that we're going to cover in chapter 4. So everybody get your notebook out. Let's get your notes today titled Lesson 4-11, and we're going to learn about expressions today. Okay, an expression, and we're not talking about a facial expression. No. We're talking about a math expression and what that thing is. Okay. And you're going to see here in just a moment when I give you some notes for today what a math expression is, okay? We're obviously going to kind of build off of what we did yesterday. So do you think expressions are going to kind of go along with order of operations? Yep. Yes. It makes sense that this lesson immediately follows order of operations. So these things kind of go together. And you're also going to kind of see that it's not a lot different than what we just did yesterday, okay? You know what I did just remember though? I promised Shane that I would work one of those problems that had those weird brackets. So let's take a quick jump away from this for a second and look at one of those because people at home can afford to kind of use that also. Let's see, y'all can have a work. So let me look.
I said 20 on the front. No, there's no 20 on the front.
Okay, so let's do, all right, this baby is long, no, not that one. Number 14, yeah, your eyes are better than mine. On number 14. Read me what that says. All right, go, I'm ready. Tell me if there's a bracket, like a bracket's in front, right?
Bracket 3 plus parentheses 34 minus.
Hang on, what was that? People, stop talking. I can't even hear her and she's literally 2 feet from me. What?
Bracket 3 plus parentheses 34 minus 1 parentheses bracket divided by 9 plus parentheses 18 plus 3 parentheses.
Oh, the heck, yours. How great that would be. Okay, so thank you, Rory. All right, so this is kind of the problem that you were looking at. And some of you were able to kind of figure this out on your own, but let's go ahead and just kind of give everybody a chance to kind of see this. Can you see good enough from your angle? Okay, I know sometimes I end up getting in the way, so you can sit down here for me too. What I want you to think about when you see these funky bracket things, it's just like parentheses inside of parentheses.
Yeah.
It's like when you are opening up a Christmas gift and you have a big box, and inside that big box is another box, right? And then inside that box is the gift, okay? So, or maybe there'd be another box. Like you could have that. You could have multiple parentheses going on inside of a problem. All those brackets is just another set of parentheses. But instead of making them look like parentheses, they kind of change their formation a little bit just so that you don't confuse them with the other parentheses that are there, okay? So in this particular problem, if we follow the order of PEMDAS, which is PEMDAS, parentheses have to go first. So technically, there's 3 different sets of parentheses in this problem. The brackets are creating parentheses. This has parentheses, and then this are more parentheses. So we need to really train our brain just to go ahead and start on the left because that's how we traditionally do things with order of operations. So the stuff on the left are the brackets, and then inside those brackets are parentheses. So what should we do first, Max?
34 minus 1.
Yes, so inside of those brackets is a parenthesis. So we're going to go ahead and take care of the stuff that's in those parentheses, which is 34 minus 1. And 34 minus 1 is a pretty easy math problem, Max. What is it? 33. And then I'm going to go ahead and bring down all the other stuff that I haven't used. I haven't used this bracket, so it's going to come down with it. I'm going to keep my plus sign, my 3, my other bracket, okay, because I haven't used those yet. My division sign's gonna stay, my 9, my plus, and then all this stuff here at the back, okay? So I've eliminated one of the parentheses. Now it's time to kind of do some more parentheses, because now I still kind of have 2 of them, right? These brackets are kind of making a parenthesis, and then I got these down here. But if I want to train my brain to keep working left to right, let's go ahead and do the parentheses that are on the left, all right? So what's my next step? Yeah.
You have 3 plus 33 would be 36.
Perfect.
Then you bring in everything else.
Excellent. So there's my answer. See, I opened up my box and out comes 36. And then I drag everything that I have not used yet down. Okay. Now you will get to a point, friends, when you become so comfortable with this that you don't literally have to do one little thing at a time. You will get to the point that you can do this and this all at the same time. And then you just kind of bring that down. It saves you some steps, but we are in the baby stages of learning this. I don't want you jumping to that yet, okay? I want to see everything that your brain is doing. And I know that creates 2 and 3 pages of work pages on homework assignments, but that's okay, okay? That's just sometimes future math will include lots of work. So we're kind of learning to get comfortable with that now. All right, what's next? Yes?
You would do 18 plus 3 since it's in parentheses.
Which is?
It'd be 21.
Yep. So I've got 21, drag everything else down. I'm getting super close to the finish line. Okay. Now I have no parentheses left, so I can finally get away from the P in PEMDAS. I have no exponents, but the next category that I get to is multiplication and division. And PEMDAS tells me I have to get rid of all multiplication and division before I can ever start any addition and subtraction. So Tessa, what's the next step?
36 divided by 9.
Which is?
4.
And then drag down your other stuff. 4 plus 21, everybody is?
25.
That's why your answer for that problem was 25, okay? So does that make sense now?
Yeah.
So if you see those little bracket things, don't have a panic attack. Just know that that's just another set of parentheses, okay? Yes, Cassidy. Shh, I can't, Cassidy raised her hand, but for some reason I hear 15 other people. What?
I can't do it now like I do all the parentheses at once, but for the bracket, my mom told me like do the parentheses and then add it and then split it down as 100.
So you did, so you kind of took care of like 2 steps in one, and that's okay. That's what I'm saying, we're gonna get to where we can do that, and if you're already ready for that, then that's okay. So you're telling me that you just did 34 minus 1, which was 33, went ahead and added that 3 and made it 36. So you brought out 36 right from that start.
That's what I did.
And that's fine, but not everybody can do it that easily, that quickly, okay? So some people just need to see every step. So that's why I'm kind of teaching with every step, but if you're ready to kind of do multiple steps in one, that works for me, okay? As long as you don't have silly errors along the way. All right, so are we good on that?
Yes.
Okay, let's go back to kind of what we're now learning about today, which is this expression stuff though, okay? So what is an expression? Well, an expression is this. I'll let you write it and then I'll talk. Okay, so as you can see from what you just took in your notes, an expression is a math sentence. Well, now first off, what do you think I mean by that? Or the book means? So what does the book mean by that? Dominic?
Like 42 plus 36.
Excellent. Excellent. So a math sentence is a line of numbers and math symbols that are all put together to tell a story, okay? If it's a word sentence, then we use words and we use punctuation like commas and periods. Those are word sentences. But if it's a math sentence, it's going to use numbers and it's going to use math operation signs, okay? So all an expression is basically a math sentence that's used to tell a story, okay? And a lot of times you see these in word problems. So if I gave you a little tiny baby word problem like Sally had 6 cups, Julie gave her 3 more. How many cups does Sally have?
9.
But if I ask you to write that as a math sentence or as an expression,
6 plus 9.
what would your expression be?
6
plus 3.
Okay,
That's it, okay? So an expression is just a fancy term for a math sentence, all right? So as we continue to kind of explore these expressions, we're gonna have to use, because we're not really using baby math, right? Most of the things that we are going to see are going to involve multiple numbers and multiple math operations. So that means we're going to need these things called grouping symbols. So write down what a grouping symbol is.
Isn't a grouping symbol be like parentheses?
Yes. Beautiful. And here in a moment, you're going to probably all look at me and go, didn't you teach us to do this yesterday? No. And I'm going to say, yes, I did.
Then why are we doing it?
Yeah,
we just simply time
Why
our
do you
same
waste
Yeah, why can't
I'm glad the people at home are getting to see all of you all arguing about that you just want to sleep.
Yeah, but
Okay, so a grouping symbol, they are used to show what part of the expression you're going to do first. And that's pretty much what we have just learned how to do yesterday. So anytime I would draw those parentheses around a section of the problem, you were creating grouping symbols. That's what you were doing. You didn't know that's what you were doing yesterday, but today, that's what you know you're learning to do, okay? So let's kind of look at an example of a problem. Okay, copy that problem down. This problem here has 2 sets of grouping symbols. So it has those brackets that we talked about yesterday, as well as inside the brackets, it has parentheses. Those grouping symbols tell me what I'm going to do first when I start to solve the problem. But unfortunately, some problems won't give you the grouping symbols, and so you have to figure that out on your own. And that's where you have to know the order of operations. So now you should be able to solve that, so I'm going to give you a minute to solve it.
We're supposed to solve it.
Yes. Yes. For those of you who have already done so, great, sit tight. For those of you who have not, give it a shot. And if you want to knock out 2 things in one, kind of like Cassidy was telling us earlier, you know that you have to do all the stuff inside the box first before you can do anything with the +9. So you might be able to right now do that stuff inside the box in your head. And you know what you're going to pull out of that box. What am I going to pull out of my box when I do my 4 + 5 and then times that by my 3? Everybody?
27.
I'm pulling a 27 out of that box. How many people need me to kind of show them how I got that?
No.
4 plus 5 is 9. Times those 3, 27. Then you just bring down your leftover business. You really don't need to, why would I not need to put grouping symbols on 27 plus 9?
Because you already unboxed it. You don't need that.
Right, because do I have any other math operations in this sentence?
No.
No. And the only time I would need grouping symbols is when I'm looking at like more than one math operation. In this section here, all I have is an addition problem. So I don't have to draw grouping symbols. 27 plus 9, everybody is?
36.
36. Okay. So let's practice some because again, that's how we get good at this stuff. And it is by, I'm going to erase this only because the next class that I do this with, I don't want them to see the answer, okay? All right, so let's jump to this page. So here's our practice time. So what I want you to do, the first problem does not have grouping symbols. So the hint in red says, use grouping symbols to see what to do first. Okay, so the first thing you need to do is copy it down. Obviously, you can tell the stuff in this problem does not look crazy hard, but you have to pick the right thing to do first, or else you're going to get to the finish line with the wrong answer. So make sure your grouping symbols go in the right place. And I don't want anybody to finish in the wrong spot. So let's share. Where should our grouping symbols go first in this problem? Henry.
18 divided by 2.
Thank you. Beautiful. Our grouping symbols should start right there. How many of you started there? Good, good. Why did we start there? Why did we start there, Henry?
Because
This is higher level thinking, being able to explain it to me. Why did we start there?
the dividing goes before multiplication.
Ooh. I like that you said the multiplication and division comes before addition and subtraction, but I don't like that you said division always comes first.
No.
Because it doesn't.
No.
What? Let him have a chance.
You're gonna go left to right.
Yes, there it is. Because you go left to right. And in this problem, what's the sign that's on the left? The division. The division sign's over here, the multiplication sign's over here. So if I'm trying to figure out which of those two I gotta do first, I go left to right. And so that's why they go there, okay? What's 18 divided by 2, everybody? 9. So I'm gonna pull my 9 out of my little parentheses. Then I'm gonna bring down everything else that I have left, okay? All right, now, I still need my grouping symbols. Because I have two different math operations going on in this problem here. I've got a multiplication sign and a plus sign. Sophia, where are my grouping symbols going to go next? Yes, why, Sophia?
Because did you go left to right with your and as it's division and it's multiplication and division, but you go left to right with that word, so it makes the multiplication.
Well, what if the multiplication was over where the plus sign is?
You'd still do it.
I would still, because multiplication and division always comes before addition and subtraction. Okay. 9 times 12, everybody is? 108 plus, whoopsies, plus my leftover 8 is? Good. All right. I'm going to give you the next two, and you're going to complete those without my help, okay? And then I'll let you know what those answers are following.
How long are you gonna get?
How about we get, let's do 2 minutes per problem, so that would be
So short.
4 minutes. There they are. I will give you until 9:46. Actually 47, because it's about to turn. Your brain will work a lot better if you stop your comments and focus on the problem.
Do we do both of them?
You're supposed to do both of them. Now, when I give you a time frame, that is not, the point of that is not to get you to speed and to race. It's to keep you focused. And it's also to get you to understand that in life, we sometimes are locked into a certain amount of time to get something done. And I want you to start focusing on trying to get a job done within the amount of time you've been given. I'm gonna give you some more minutes because I think that second one could be a little bit of a doozy. So let's give you until 48. That's 4 more minutes. For those of you still working, you've got about a minute and a half left. So if you did finish, make sure you didn't do something incorrectly. Make sure you didn't, multiply, divide, add, subtract, wrong. Make sure you didn't put your grouping symbols in the wrong location.
Number 3 was a good shower. Number 3 is it was a good shower.
Number 3 is not easy. I still see pencils moving, which means some individuals are still thinking through the problem. Hang on just a second.
Okay.
Now, what we're gonna do, because I'm gonna give you all a chance to kind of get up and move a little bit, okay? So we're gonna kind of play the corner game, okay? So if we were at the skating rink, the corner game would mean like you would pick a corner that you would go to based off of where you think they're gonna call a number. But because we're not doing it that way, we're gonna go to corners based off of who you think, what you think the answer is going to be. Okay. So in problem number 2, who thinks they have an answer that they're strong and confident in what they got? Rory, what'd you get? Rory got 13. If you agree with Rory, go stand in the back corner where Shane is. Now, don't, listen. I don't want you to change your answer. And you have to be honest because you don't know what the answer is. Okay? So stick with your answer. Just because you see so many people go one direction, they could all be wrong. Okay? You might be the one that's right. What'd you get? 12. She got 12. Anybody get 12 with her? What'd you get? 57. What'd you get?
55 over 7.
55. What'd you get?
I did it wrong.
What'd you get?
I got 52.
Okay, so each one of you, we're gonna kind of let you all hang there. Obviously, it looks like the majority of the crowd is believing that the answer is 12, okay? So, 13. She was really close. What'd you get? You were lost in the crowd. Huh? 112. All right, well, Bodie, since it's your birthday, come on up to the board. I'm gonna let you work this problem. Bodie's gonna tell us what he's gonna do first. He's now the teacher of problem number 2. Use your voice, Bodie, because people at home are listening to you. Brody, that's what I meant. Sorry.
So, first I'm going to do the numbers in the parentheses because at the beginning of PEMDAS it says to do parentheses first.
Okay.
So, first I'm going to do 60 minus 5, which is 55.
People in your seats, check and see if
I
you're
figure
doing
out-
what you did.
What has to get times by this? I'm gonna try. I know 10 is 50, so that's not it. It's not 55.
Okay, can I give you a timeout real quick? You're doing great, you're doing great. But these people in their seats, they might be sitting there going, hold up, what's he doing? Okay? So what he has done here, excuse me, what he has done here is he has taken the problem that's on the top of his fraction, which was 60 minus 55, and he got 55, right? So underneath, he just chose to write it up above, but what I would really like to see you do is to then write that new fraction underneath. Now, people in your seats, I want to ask you, what in the world, what kind of math is going on when we look at a fraction? Especially an improper fraction like that one. Braden, division. So now we're going to go back to Brody because he's trying to figure out how many 5s will fit into 55. Go ahead.
So 10 is 50, so that can't be 55. And I know that 11 times 5 is 55. So 11 will be your number here. So 11 fits into this. And then you bring it down, so 11 plus 2 equals 13. And so this is your answer.
So, do you people at your seats maybe see where you made your error? You probably, Olivia, had to have one little tiny baby error somewhere. Because you were so close that there had to be a place that you just made one tiny little mistake. Where did you find your tiny error?
I don't know.
She's not sure.
Different way.
Okay, let's see. So you got, all right, I can see what she did right away as soon as I looked at her paper. Okay, so let me show you all as the crowd and see if you can be a strong friend to Olivia and say, girl, here's what you did wrong. Okay, all right, ready? Here we go. Let me get rid of this little stuff here. So here's what Olivia did. This is what's on her paper. Watch and see. Ready? Olivia went like this. She had 55. She had that over a 5. And she did this.
No.
Where'd she go wrong? What did she do? Brody, you're the teacher right now. What'd she do wrong?
So, Miss Olivia, you have done this wrong because you didn't see what could fit into 55. You just put 55 plus 2, and that's not what you do. So, you erase this.
Okay.
Good. Oh, you got it.
Let me help you out. Well, can I also say one thing though, real quick, before you get too deep in your explanation? Did 2 ever start on top of the fraction?
Never.
So why did it ever get on top of the fraction?
Because that's what she thought was right.
You started moving numbers around, and you can't do that, okay? The only time we're allowed to make changes to numbers in math is when we're estimating. We're not estimating here. So if the 2 never started above the fraction, it should never have ended above the fraction. So you should have kept this stuff, girl, out here on its own little island. Okay? Then where should her grouping symbols have gone? Where should the grouping symbols have gone then? If we were looking at a 2 plus 55 over 5, Hallie, where should they have gone? Yeah, they should have gone right here. Because this is division, and division always happens before addition. Even though the division was way over here, it has to go first. So that's where he figured out, what is 55 divided by 5?
11.
His brain, after he processed all of it, said it's 11. And then he brought down his extra stuff. That's where 13 came from.
Can I answer the next
Don't put 2s up there if they don't need to be. Okay? All right. Let's try this other one that was somewhat of a beast. Okay?
I couldn't do it. This belongs.
All right. We're running a little bit out of time, y'all, and I promised you that I would give you some time to work on your oh my gosh, come on. Okay. So let's have Brady, come on up, buddy.
Hey, I can't.
Yay! All right. Okay, well, yeah, Brady, what'd you get for your answer real quick? 7? All right, Brady, if you got 7, go join that corner. Brady, but I need you because you're going to work this. Okay. All right, you don't have as many people. You don't have as many people traveling. All right. Who got something different? They're like, wait a minute, those people are wrong. What'd you get, Connor? 12? 112? Anybody else got 112 with him? No. What'd you get?
I got
27. Anybody get 27 with Allie? No. What'd you get?
I got 2.
2? Anybody else get 2? What'd you get?
I got 6.
6? Anybody else get 6?
6 is close.
What'd you get? You didn't finish it? All right. Well, it looks like everybody in the seats are still kind of like got different things. So it looks like the majority of us again are feeling like it could be 7. Brady, use your voice to teach the people at home as well as Brody did.
So first we do 2 times 2, which would be 4.
Really, let's not use the
Oh, I
little,
didn't know that one.
yeah.
Oh. That is what you get when you.
Don't choose the little like dotty dot lines. Okay.
2 times 2, which is 4. Then you would bring everything down.
Pay attention, people, to what's going on, especially, I don't know the answer. So especially if you didn't get what these people over here got. Okay,
Then you would, well, what I did, I went to this 6 times 5.
Okay.
And then got 30. And then brought everything down. Once I did that, I then did the 32 minus 30.
does it matter? Does it matter that he chose to come over here and do the subtraction parenthesis before he chose to do the division parenthesis?
No, they're both parentheses.
That's right, doesn't matter, they're both parentheses,
Then I
so.
brought everything down.
Could he have done 56 divided by 4, like right now in that line?
Yeah.
Yes, he could have, but he's choosing to do it one piece at a time.
Then I went to the 56 divided by 4 and got 14.
Oh, I did 12.
And then brought everything down.
There we go. So, she found her error. Did you find your error?
I found mine.
So let's look line by line. So your second line, 56 divided by 4, divided by 32. Okay, your second line looks the same. Boys and girls. At this point, you return to your seats, okay? We're trying to see what I'm looking for these people who maybe weren't standing in that corner. I'm looking to see if they can use their higher level thinking skills to find where their mistake happened. She did it. She found her mistake. That is learning. She didn't need me to stand over her and say, this is where things went wrong. She noticed it, and it was a baby mistake. 56 divided by 4, she accidentally said it was 12, not 14. And that's gonna throw everything off, okay? So 56 divided by 4 might be something that you can't do in your head. So because you all wanna do so much in your head, and I don't advise you to do it in your head, come over here and write out the problem and figure it out the long way. That's why we learned how to do division before we learned this stuff. Because you gotta know how to do division before you can do order of operations, okay? So Olivia, we're staring at your problem here. Your second line, which is this, matches exactly his line. Let's move to the next line. What do you see in your line number 3? Okay, it looks the same. So that means we still haven't gotten to a point where there's an issue. So now it's time to look at this line. Follow that line. But wait, follow the line. Does his line match your line?
Yes.
Yes. So far, all of these steps you've done correctly. So where did things change for you?
I thought that 4 pound been 56 9 times. So
No, you didn't say 9, you said this.
Oh.
Out of your box, when you did 56 divided by 4, the number you pulled out of that box was what number? 20. And I think that's because you tried doing it in your head. And I can say that because I look on your paper and I don't see anywhere on your paper where you did 56 divided by 4. So that mistake, 56 divided by 4, that's where things went wrong. If this would have been a 14, what's 14 divided by 2?
7.
And you would have been standing in that corner, okay? So use your skills to write things down instead of always trying to do so much up top. Okay, so let me see what is next. I do want to show you one other thing before I set you free on homework, okay? So sometimes you have to write an expression. Like those that we just saw, you guys, those were all things that I gave you. I gave you the expression, and all you had to do was just find where to group them, okay? But sometimes you have to write the expression on your own, okay? So I want you to write down, this will be the last thing we do, okay? I want you to write down, like, well, first off, you need to have in your notes what our title is, and our title, like, for this little section. We're still in the same lesson, so you don't have to go to a new page, okay? But writing expressions. So remember how I started class today by kind of giving you a word problem, and it was kind of a real baby word problem. It was about Sally and Julie getting cups, right? But sometimes when you're looking at a word problem, it's your job to figure out what expression to write, what math sentence to write. So if this is the math story, if this is the word problem, I want you to write a math sentence that tells me what's going on in that story. And the story says, Mila has 3 packs of pins. Each pack has 10 pins. She loses 2. Okay, that's the story. But what does that story look like as an expression? What does it look like using numbers and math symbols? Okay? So this is what you're trying to figure out. Now think. This is higher level thinking skills. Chill. It's higher level because I didn't just give you the problem, but I'm asking you to read what you see and create a math sentence based off of those words. This is when you get word problems on your test. And what do all of you come to me and do? As soon as you see these word problems, you crawl over to me and you look like a starving little child that's needing help. I don't know how to do these. This is no different than what we've already done. It's just instead of me giving you the actual problem, I've set it up as a story. And I'm asking you to write it out. So, Braden, come on up to the board.
Why are you doing these? Why can't you do
Oh, weird, I didn't realize.
You do
My brain's in the B mode right now. Okay, so Braden, using your voice, what is this gonna look like as an expression?
It's gonna look like 3 times 10
Why?
because there's 3 packs of pins, and each pack has 10 pins.
Okay, beautiful.
Minus 2 because she loses 2 pins.
Excellent. So the 3 represents the packs, and the story tells us that in each pack is how many? 10. But then she loses 2 of them, and so we know, our brains know that the operation for losing something is subtraction. And so now he's got his expression created. If you were going to solve this thing, hit the little extended page there at the bottom to give you more space. Just tap it. There you go. So how would you group this to solve?
Put parentheses around the 3 and the 10.
Okay, go ahead and finish it out.
And then 3 times 10 is 30. Bring down. 30 minus 2 is 28.
So how many total pins does she have?
28.
Okay. All right, your homework assignment this evening is going to be for you to complete workbook pages 71 and 72. Now, it's 10 o'clock, and technically, remember, we don't have, thank you girls for doing that. We do not have, I told you I was giving you time, so you have study hall now. Between now and 10:25, when math would be over, to work on this assignment, okay? If you choose to not work on your math assignment because I'm giving you a study hall, that's fine. But it's on video that I gave you time to work on your math homework in class. So if you are at home spending lots of time on your math homework, that's your choice then, because it means you're choosing not to take the minutes I'm giving you to work on it, okay? I will be here to help you while you're kind of working, but if you're choosing not to do the math and you're choosing to do something extra, that's fine, because it's your choice, it's your study hall. But I hope that means you know how to do all this on your own now, okay? All right, hang on. You may have your snack, yes, because it's snack time.